Okay, so now we are going to do a more complex mesh analysis. And in here we are going to apply the fact that it has to be all voltage sources. So we have to make a transformation in order for us to be able to use mesh analysis. So the first step is they're asking us to write the loop equation necessary to perform a mesh analysis of the circuit. So this has three loops, 3 divisions of the circuit. So we most likely are going to have 3 unknowns. So that's why they are asking us to just write the equations, okay? Not to solve it. So, but the first thing to do is, okay, I have two voltage sources and I have 1 current source. So the rule is that they all have to be voltage sources. So I have to transform this voltage source, this current source, into a voltage source. In order for me to do that, I have to find a resistor that it is directly parallel to this source. So the 30 is not parallel because it is connected here. But in order for it to be parallel, this other terminal has to be connected to this end of the source. So this is not parallel. The 60 ohm, it is parallel because this terminal is connected parallel to that terminal, and that is connected parallel to that terminal, and there is nothing in between. So this is a perfect combination for us to make the transformation. So let's do that. Let's find the voltage equivalent using Ohm's law. So I get 24 volts. I have 0.4 amps times 60. I get 24. So I'm going to take this section. Everything else stays the same. This voltage stays the same. That resistor stays the same. What is going to change is this section right here. So I have my voltage, and now I have my resistor in series with the source. Everything else, the 40 stays there, the 50 stays there, the 15 stays there, the 10 stays there. Pay attention to the polarity. It was going up, so the current is going up. This is the negative and this is the positive for the current source, negative and positive of the voltage source. So it is fine. Now I'm going to write my loops. And I have to be very careful once I have resistors that share 2 different currents. Like in this case, the 30 is going to be sharing I3 and I1. The 40 is going to be sharing I3 and I2. The 60 is going to be sharing I1 and I2. So, and that is the nature of this method. We have to have resistors that link the currents with the other loop currents so that we can solve it. So let's start with loop 1. So this is going to be loop 1. Again, we follow the standard saying that we are going to create clockwise. Clockwise is the direction of my currents. So right here, it seems like we start at this point. So I go this way. So I get 30 times the current in order for me to find my voltage. So it's going to be I1 minus I3. Why? Because anything that opposes the direction of my loop current is going to be subtracted for it. So I1 minus I3 times 30 is the voltage drop across this resistor. Then I come here. It's going to be 60 I1 minus I2, right? Why? Because I1 comes down, I2 goes up. So it's opposite, so they subtract. And then I go here, I enter from the positive terminal, so it's 24. I keep going, I enter to the negative terminal, so it's negative 12. And then I end where I start. So 12 positive equals to 12, because negative 12 taken to the other side is positive. Then I do loop number 2. Loop number 2, it seems that they start right here. So right here I'm going, I2 goes up and I1 comes down. So it's going to be 60 I2 minus I1. Anything that opposes the direction of my loop current is going to be subtracted. I continue, I2 is going to be 40, I2 goes this way, I3 goes this way, so they subtract, so it's going to be 40 I2 minus I3. And then I get here, it's going to be 50 times I2. I come here, it's going to be minus 24. equals to 0. But if I take the minus 24 to the other side, it's equals to 24. Now I'm going to do my third loop right here. Let's see, they started at this point. So I go this way, is 10 times 100 times I3. Then I keep going. It's going to be positive 15, which I have it right here. I keep going. Now I'm going this way. It's going to be 40. I3 goes that way. I2 goes that way. So it's going to be I3 minus I2. So 40. Oh, sorry. I'm here. I'm here. 40, right? 40 is going to be 40. I3 minus I2. I continue. And here I'm going to have 30. 30. I3 goes that way. And I1 goes that way. So it's going to be I3 minus I1. So 30 I3 minus I1, and then I equate the whole thing to 0. So these are my three equations with how many unknowns? I1, I2, and I3. So I have three equations. I better have three unknowns, and that is exactly what I have. So right here, I just simplify and rearrange equation 1, equation 2, and equation 3. So if you do the math, multiply the 30 in, the 60 in, the 60 in again, the 40 in again. This is just simplify. You get 90 I1 minus 60 I2 minus 30 I3 equals negative 12 and negative 16 plus 150 I2 minus 40. So you have a system of three equations, three unknowns. So you can solve it, or you can just leave it like that, so that the math we are not so interested in, because this is not a math class. What I'm most interested in this section is that you guys do understand how to apply mesh analysis and how to be able to solve the equations. What you have, you get to this point, is easy. It's just math analysis. So that is the example for mesh analysis.